A look at the fifth question, x square minus 5x minus 14. Let's try and solve this again using completing the square. So to complete the square, you need to locate b, which is the coefficient of x, and b by 2, b here is minus 5. So b by 2 will be minus 5 by 2. The magic number is b by 2 whole square, which is minus 5 by 2 whole square, which is 25 by 4. Now this is the number that needs to be added and subtracted to the equation. So x square minus 5x plus 25 by 4 minus 25 by 4 minus 14 equal to 0. Now this will be nothing but x minus 5 by 2 whole square. Let's confirm this using our formula. A minus b whole square is a square minus 2ab, so that's minus 2 into a into b, right, plus b square, which will be 5 by 2 whole square, so that's 25 by 4. So you got that as x square minus 5x, since 2 and 2 cancels, plus 25 by 4. So yes, this can be written, the x square minus 5x plus 25 by 4 can be written as x minus 5 by 2 whole square. Remember, it will always be x minus b by 2 whole square. And over here you can write, actually, why don't you do this? I will send minus 25 by 4 to the right hand side, so it becomes positive, and minus 14 also to the right hand side, so it becomes 14, positive 14. So x minus 5 by 2 whole square is equal to cross multiplication. Remember, if you are doing cross multiplication, you can think of this as 14 by 1. So your LCM, or in the denominator you will get 4. In the numerator you will have 25 plus 56, which is equal to 81 by 4. So x minus 5 by 2 will be root under 81 by 4. So x minus 5 by 2, okay, let me just write it here, which means plus or minus 9 by 2. Root of 81 is 9, plus or minus 9, and root of 2 is root of 4 is 2, so plus or minus 9 by 2. So one of your x values will be x minus 5 by 2 is equal to 9 by 2, and the other will be x minus 5 by 2 is equal to minus 9 by 2. Solving both, I will get x as 9 by 2 plus 5 by 2, which is 14 by 2, 7. And over here I'll get x equals to minus 9 by 2 plus 5 by 2, which is minus 4 by 2 minus 2. So these are the two roots that you have arrived at using completing the square method. Our sixth question asks you to use the quadratic formula. So given the general form ax square plus bx plus c equal to 0, your quadratic formula says x is equal to minus b plus or minus root under b square minus 4ac whole divided by 2a. So in this equation, my a is 2, b is 1, c is minus 528. So the x values will be minus 1 plus or minus 1 minus 4 into 2 into minus 528. Remember, the signs are important. Whole divided by 2a, which is like this. So it's minus 1 plus or minus root under. So use your calculators. You will get this as root under 4225 divided by 4. So your x is equal to minus 1 plus or minus root under 4225 is 65 divided by 4. So your value of x is equal to minus 1 plus 65 by 4, or the second root is minus 1 minus 65 by 4. And this is minus 66 by 4 minus 16.5. So your two answers or two roots are positive 16 and negative 16.5. The next question is 6x square minus x equal to 5. This is the 7th question, and to get it in the general form, let me just ax square plus bx plus c equal to 0. I'm just going to bring 5 to the left hand side. So it becomes negative 5 is equal to 0. This is because on the right hand side you are left with nothing, and nothing means 0 in maths. So now it's in your convenient ax square plus bx plus c form, where a is 6, b is minus 1, c is minus 5, and your formula is minus b plus or minus root under divided by 2a. So putting these values into this equation, you will get x as equal to minus of minus 1. Remember, that will become plus 1 plus or minus b square minus 1 whole square will be positive 1 minus 4 into a, which is 6, into minus 5 divided by 2 times a, which is 6. So that's positive 1 plus or minus root under divided by 12. So your value of x is 1 plus or minus 11 by 12. So the first possible value. Some books actually denote the first factor as x1 and the second as x2. You can also do that, I don't mind. So 1 plus 11 by 12, which is 12 by 12, which is equal to 1. And the second root of x is 1 minus 11 by 12 minus 10 by 12 minus 5 by 6. This is the simplest form that I can leave it in. So your two roots are positive 1 and minus 5 by 6. Your last question, the equation given to you is x square plus 4x plus 5 equal to 0. The question explicitly asks you to find out if this equation can be solved. That is, does it have any real roots? If it does, use the quadratic formula to solve and find the roots. Now, checking whether an equation has real roots, you only need to check the value of the discriminant. The discriminant means the value of b square minus 4ac. Okay, if you remember, this is the part that comes under the root in the original quadratic formula. So if this value which comes under the root b square minus 4ac, if the value of this expression is negative, you can always confidently conclude that the quadratic equation does not have any real roots. So here, to find out if it has real roots, I'm just looking at the value which comes under the root, that is the value of b square minus 4ac. Remember, this is called the discriminant. Okay, so as you can see here, a's value is 1, b's value is positive 5, and c's value is a's value is 1, b's value is 4, and c is positive 5. So the value of d, which is b square minus 4ac, will be 4 square minus 4 into 1 into 5. So 4 square is 16, and this is minus 20, which means minus 4. So you can conclude, since the value of the discriminant is negative, this quadratic equation will not have any real roots. Okay, check the same for question 4 that I have given in this assignment. You will notice that the value of the discriminant in that case too is a negative number. And if the discriminant value is negative, you will always have imaginary roots for the quadratic equation, because this discriminant comes under the square root symbol, and you cannot find the square root of a negative number. So I guess question number 4 should have been grouped along with this last question to check if it has any real roots. If it does, you can always use the quadratic formula. But in this case, since it doesn't, all you have to do is write that it does not have real roots, as the value of discriminant is negative. Or in the, like you wrote in the earlier case, as you cannot find the square root of a negative number. Okay. Thank you.